Hello everybody and welcome back to another higher maths lesson. We're still on the straight line and today we are going to be looking at proving if points are collinear or not. So this should be probably a new word to you, collinear. And what we're going to do is we're going to be given 3 points and we are going to prove if they are collinear or not. So basically we're going to take those 3 points and we're going to show that they lie on the same straight line. Okay, for example, if our points are like this and they lie on the same straight line, they would be collinear. If our points were like this, they don't lie on the same continuous straight line, so they wouldn't be collinear. So to do this, what we need to do is we need to find the gradient of that part of the line, and then we need to find the gradient of that part of the line. And if those gradients are the same, then they're parallel lines, which is the first step on the way to proving they're collinear. And then we've just got to show that they share the same point, and then that will prove that they are actually collinear. So we're going to be given 3 points. We're going to split this up and we're going to work out the gradient of 2 lines, and then we need to have a look at how we communicate our final answer. So for example, if we had the points P, which is -6, -5, Q, which is 0, -3, and R, which is 12, 1. We are going to show that these points are collinear. So the first thing I'm going to do is I'm going to take my first 2 points, P and Q, and I'm going to find the gradient. So we've done the gradient formula, y2 minus y1 over x2 minus x1. I'm not going to write this formula out for every single question that we're doing, because we should now be in a position where we know it. We should know how to label our points. I'm not going to go over that in detail every single time we do a gradient question. Okay, so y2 take away y1. So I've got -3 take away -5 over x2 take away x1, which is 0 take away -6. So -3 take away -5, that'll change to add. That'll be -3 add 5, which will take me up to 2. 0 take away -6 will be 0 add 6, which takes me up to 6. My answer of 2/6 I shall simplify to get a third. So there's my first line. My first line has a gradient of a third. Now I'm going to look at my second line. For my second line, I'm going to look at the gradient of QR. So same as before, we're going to do a gradient formula. I'm not going to write it out. I know it's y2 take away y1, x2 take away x1, 1 take away -3 is 1 add 3, which is 4, 12 take away 0 will be 12, 4 over 12 simplifies to make 1/3. So we do have equal gradients. Now, just having the same gradient doesn't actually prove we've got one continuous straight line, because you know that having the same gradient just means they go in the same direction. It doesn't prove that they are on the same straight line. What takes this from simply being parallel to be collinear is the fact that both these lines go through point Q. As both of them go through point Q, there's Q, P to Q, Q to R. As both lines go through Q, it now means that they are collinear. Okay, so to be collinear, there are 2 things that need to happen. You need to have equal gradients. They also must go through the same point. How we communicate this answer is very important. In higher maths, what you will find is that how you actually get across your answer, we're now expecting much more detail than you would have done in National 5. Okay, so if I'm writing this out, I would say as the two gradients equals each other, the lines are parallel. Okay, that's the first thing we found out. As both lines go through Q, then P, Q and R are collinear. We need all that information in our answer. So we'll find out the gradients are equal to each other, which means we have parallel lines, but because they also go through Q, it means that these points are collinear. So if you are asked to prove if something is collinear or not, what you need to do is you need to go to your 3 points, split them up into 2 lines, so PQ, QR, find the gradients of both of them. If they are the same, then we're just going to make sure they share the same point, and that means they're collinear. If the gradients work out to be different, then that simply means that they're not collinear, and we can just stop it there. Okay, time for you to try some questions. So question number 1. Which sets of points are collinear? So you can see the points there. So you can try that. Number 2. Again, you can try them. Number 3. And number 4. At this point you should pause the video and try the 4 questions. Okay, let's try and prove if they're collinear or not. So what we need to do is we need to get the gradient of AB, which is going to be 0 take away minus 3, minus 1 take away minus 5. That will give me 3. This will give me 4. I'm then going to find the gradient of BC. So it's going to be 6 take away 0, it's going to be 7 take away minus 1, which is going to give me 6 over 8, and 6 over 8 will simplify to make 3/4. Okay, so gradients are the same, and both lines go through B, so it is collinear. Again, the writing out of this answer is important. So as the gradients equal each other, that tells me that the lines are parallel. And as they both go through B, the points ABC are collinear. No taking shortcuts with the explanation. It needs to be detailed if you're going to pick up the marks. Number 2. Okay, so we've got PQR this time, so we're going to do the gradient of PQ, which is going to be 3 take away minus 6, minus 1 take away 2, 3 take away minus 6 is 3 add 6, will make 9, minus 1 take away 2 will be minus 3. Right, now, in this situation I have 9 divided by minus 3. So 9 divided by 3 will give me 3, but there's a negative involved here. So my gradient is minus 3. I don't need to write minus 3 over 1. Minus 3 is perfect. Then I'm going to do QR. So it's going to be 8 take away 3, minus 3 take away minus 1. 8 take away 3 is 5. Minus 3 take away minus 1 is minus 3 add 1, which will give me minus 2. Okay. The gradients are not the same, so they're not collinear. How I'll communicate that is this: as the gradient of PQ does not equal, remember, an equal symbol with a line through it just means does not equal. As the gradients do not equal each other, the points P, Q and R are not collinear. Okay, number 3. So we've got S, T and U. So we're going to do the gradient of st minus 2 take away minus 6 over 2 take away minus 5, which is going to give me minus 2 add 6, which will be 4, 2 add 5, which will be 7. But then going to do the gradient of tu, which will be 2 take away minus 2, 10 take away 2. 2 take away minus 2 is 2 add 2, which is 4. 10 take away 2 is 8, which is 4 over. Okay, so that will give me a half. Again, gradients are not the same, they cannot be collinear. And that's how we would express our answer. Last one. Oh, I bet you a fiver this is going to be collinear. So we're going to go EO, the origin. So that's going to be 0 take away minus 4, 0 take away 6, 0 take away minus 4 will give me 4, 0 take away 6 will give me minus 6. Now 4 over 6 will simplify to make 2/3. The negative symbol, sometimes people get a little bit kind of caught up on this. It doesn't technically belong to the bottom, it doesn't technically belong to the top. It just means that I have a negative fraction, so the negative symbol can just go at the front. Then I'm going to do the gradient of OF. So that's going to be 6 take away 0 minus 9 take away 0, which will give me 6 over minus 9. Again, 6 over 9 will simplify to make 2/3, and it means I have a 1 negative, so the fraction is a negative. Okay, so the gradients are the same, so we're on our way. Do they share a common point? Yes, they do. They both go through the origin, they both go through O. So let's communicate our answer properly. So as the gradients equal each other, the lines are parallel. And then as they both go through O, the points E, O and F are collinear. And that is how you prove points are collinear. Remember, if they're collinear, they lie on the same straight line. To show that, you need to work out the two gradients and show they are the same, and then also show that they go through the same point as well. Thank you very much, everybody. I'll see you next time.